Hello, this is a short video about how you might kick off a project, particularly a software project, but also any general product development effort. It's good to sort of follow this idea or the ideas presented here. Doesn't matter what your methodology is, whether it's agile or whether it's waterfall or whether it's some other approach to organizing the work. Most of these ideas still apply. It's just the cadence or the time between when you're applying them is sometimes different. So let's start off. This diagram on the screen is called variously the system V or the design V, and it captures all the sorts of steps that you should see in a development project. So we start off over here with the concept of operations. Okay, so concept of operations is, what's the idea? What are we trying to achieve? Usually this has got to happen in consultation with the customer or the people who are going to be using the system. If you don't talk to the people who are going to be using the system, you're liable to miss lots of things, lots of nuance, lots of details about how the system can help them do their jobs. Once you've got that idea of what the system is, then you want to nail down what you're going to build. And you're not going to nail down what you're going to build by building it. You're going to write down in human readable form things about how to do it. And a way to do that is to write things called requirements. Okay, so requirements are very precise statements about the functions that the system is going to perform, or sometimes with cross-cutting concerns, how the system is supposed to operate. For example, one functional requirement might be, at a high level, the system shall play tic-tac-toe. Okay? And then an example of a cross-cutting requirement might be that the system shall be displayed in black and white. Okay, it's not a function. Black is not a function. White is not a function, but it says it's saying something about the display of the game tic-tac-toe. Okay, once you've written those down, you might want to then say something about the environment that you're going to implement it on, and often that environment statement is the architecture. And this might mean that the computer that it's going to run on, it has to be a Windows computer, or it has to be a Mac computer, or it has to be a Linux computer. It might be that you decide it's a web application, so you need a web server, and then you need to define what browsers the web application is going to be able to run in. Will it run in Safari or Firefox or Google or any of those? So that's the system architecture. It'll also that architecture diagram should also tell you something about the connections between the different components in the system. It'll also tell you what components you're expecting to be in the system. Once you get that, then you can think about detailed design. And detailed design might take the requirements and the architecture and decide that there's a component that's split over two machines. One component is in for example, the database, and the other one is in the UI, but they're related. And you figure out how to make those two work together in the detailed design. We still really haven't written any code yet, okay? The things that you would do in detailed design from a database perspective might be to draw the ER diagram. It probably also involves creating the logical diagram of the database that shows all of the primary keys, foreign keys, types of the things you expect to be in the database. Okay, then we actually have to do it. So here, from a database perspective, you might now be writing the SQL to create the tables and then figuring out how to populate the tables. From a Python perspective, the detailed design, going back up here, might be to choose what classes you're going to use, choose what libraries you're going to use, what Python libraries. And then in Python, the implementation will be creating those .py files and implementing the classes you've decided upon in the detailed design. Okay, we're getting towards the end of implementation, and we haven't done any testing yet. We haven't decided how to test, but there's various levels of things that we can do. We can do unit tests as we go along here, right? Very small tests that just test individual functions or individual classes. But then once we need to multiple classes or database tables to interoperate, then we need to do something called an integration test. Integration tests are when you try and see that the components that you've developed work together the way they're supposed to work together. I'm going to use two words, verification and validation. And they're two quite different things. Verification, let me just get a different marker. Verification is saying, does the system meet the requirements? Right, so you're testing, whether that's an automated test or a manual test, somebody has to run the test. You're testing that the requirement that you wrote down at the beginning is met. And validation is a bit different. Validation says, does the system do what the customer wanted? Right? And you can actually get a system that verifies but does not validate. And that's a really big problem, because what that means is you got the requirements at the beginning wrong, more than likely. Or you missed a requirement. Okay, that is about it. I'm going to do two separate videos now, one for the database people, one for the Python people, to talk about what I need to see in what you're doing for that approach to development, and we'll see how we go.